All right. So first of all, thank you to Alex and Chris, Michaela, Frank, Adrian for giving me the opportunity. I'll be talking about SwiftUI architecture. I'm writing a book, so I think that's a really good topic to talk about. And Michaela instructed me to Azam keep it under 15 minutes, so I'll try my best to do that. So it will be a little bit fast-paced presentation, but you can always, contact me after the session and talk about this. All right. Okay, so year was 2019. This is when SwiftUI was actually announced. And I was actually really happy to see SwiftUI because I was already working with React and Flutter. And it's very, very similar. I mean, the SwiftUI is actually very, very uh, similar to at least React from even from the behind the scene perspective. But then obviously the big question comes like, okay, well, hold on a second. Which pattern should I use? Because if I'm using UI kit, I would immediately jump on to MVC model view controller. Even if you're creating a Hello World app, it starts with a model view controller. In 2019, I didn't really think that much about it. I was like, okay, I'll just blindly follow other people what they're doing. And I started with MVVM, model view view model. Model view model was very close to me because I had worked for extremely large companies with WPF Windows Presentation Foundation in .NET, oil and gas companies in Houston, multiple projects, extremely big, huge projects. So I was very comfortable with MVVM. I already knew MVVM. So I'm like, yeah, this actually looks like a good candidate for SwiftUI. Most of the applications that I was working with SwiftUI were client server based applications. So probably if you're building anything with SwiftUI, I think your application will most probably fall into this category. Or maybe you're using Swift data or core data that's a little bit different architecture. So just like other people, I would create different screens. Like this is a movie application, so I'll create a movie list screen, add movie screen, and a couple of different screens. Now I'm using the term screen over here, which is very different from view. Yes, behind the scene screen is a view, but screen is more like a container. So screen will contain other views. And I learned this from Flutter and also from React. They call it pages over there. I mean, in React, it's called components or container components. So I learned this from React that you can actually call them screen, even though they're views, but use them as a container. For every single screen, not view, every single screen, I would have a view model. That's pretty common. If you go on YouTube, if you go anywhere, you will find these code example where if you have 10 screens, you will have 10 view models. And each view model will have some sort of a dependency to HTTP client because they need to fetch the data or perform some CRUD operation, create, update, or whatever, delete operation on the server. So they need access to the HTTP client. But immediately I started to see a problem with this approach. I mean, the movie list screen, add movie screen, movie detail screen, all they wanted is to just get access to the movies or perform action on the movie. So I was creating different view models, different sources of truth for every single screen. This means that the screen or the view model are directly proportional to the number of screens. So if I have 50 screens, I will have 50 view model. I can have 50 screen, but 350 views. But we're not talking about the views, which are reusable purposes. We're talking about screens, and screens are not really meant for reusability. They're just follow a particular container. And obviously, every single screen will need a view model, and every single view model will need a HTTP client. So somehow you need to perform this injection. And this injection just goes on forever because every screen is represented by a separate view model, and every separate view model needs a dependency on HTTP client. We also don't really have access to app storage, environment object, focus state, fetch request, environment values, and query. These things are only available inside the view. So that makes me think like a lot of things were added by Apple and I just cannot use it inside the view model. But then I went back to my existing knowledge of React. I know that React is very similar, even at the base level, it's very similar to SwiftUI. How will React solve this problem? Well, React by default uses a pattern called container presenter pattern. In a container presenter pattern, you have a container like a screen, and that container will be responsible for downloading and performing all different kind of operations. And then once the operations are performed, then the information is just sent down to the presenter pattern. So it's kind of like our screen. Screen is a container, and views will be our uh, presenters. So I started experimenting with this approach. This was my original idea. I mean, not original, but this was my original starting point where I had view model for every single screen. I said, okay, what about if I remove these view models and let these screens talk directly to the HTTP client? I mean, why can't I do that? I mean, I can do that in React, and you can create some really huge applications with it. And the code will look kind of like this. The HTTP client is then available through the means of environment value. And then I will just make the call, get the data, assign it to the local state, and then just display it. Okay, so this works out pretty good for a certain type of application. And I'm very careful with my words. I'm not saying all application or small application or medium application, but certain type of applications. Those type of applications that are only trying to get access to server, get the data. I mean, think of all the clients that you're building where your view or your app is simply a front end for a JSON response. I think you can think of a lot of applications that does that. But what if you remove view model, where will all the presentation logic go? Well, the presentation logic, not the business logic, very different things. And I think iOS community has a they confuse these a lot. Presentation logic as a logic for the elements on the screen or something related to the UI, like it's form valid. That has nothing to do with business logic. A business logic will be I cannot apply two discount codes, or if I apply one discount code, then one will be 10%, other will be 20%. This is just a very simple presentation logic. So I would just put the presentation logic, since I don't have any view models left, in the view itself. I can test it out. I mean, I can just write a test for is empty or white space. Here's another example of the difference between presentation logic and business logic. Presentation logic is something to do with the UI interaction, UI view, or UI behavior. And the business logic is actually the actual domain business rules that you must obey. That's more important than anything you can have. I'm over here using the example of Swift data, but if I have to write Swift data application, it will be a little bit different architecture than the client server application. So this is example spent and remaining. These are example of business logic, not presentation logic. And this is the example of presentation logic, not business logic. Very important distinction. Even Apple in one of their talks talk about that if you want to test out the presentation logic, you can actually use previews for testing it out. And most of the time I would do that. Most of the time I would use my previews to test out my presentation logic manually. Presentation logic, I have to, again, presentation logic, not domain or business rules. You should write tests for your business logic, okay? But even though this is working perfectly fine, but what about shared state? Sometimes or a lot of time, we will have applications where we will have a movie list screen and that will open up a modal, and that modal will be add movie screen. And then add movie screen need to communicate with the movie list screen somehow. Yeah, I can use closures and binding, but that kind of gets annoying. If they both need the same data, why can't they just go get it themselves instead of communicating through closures and binding and whatnot? Well, if I need shared state, why not just use environment? Environment object and observable. So this means that in the middle, instead of directly communicating with HTTP client, which is perfectly fine for certain type of apps, if you're building app that's shared state, maybe we can put something in the middle. Now, hold on a second. Isn't that just a view model with a different name? No. Let's go ahead and find out. A store or something, aggregate model store, whatever you want to call it, is more of a uh, one source of truth that can provide you data to in multiple views. Now, for small or medium-sized application, you can just create one store like Platzi store, and that can manage the entire state of the application. That's perfectly fine. But if you're building very large applications, then you can create your stores based on the bounded context of your application. So over here, I have multiple stores: catalog store, inventory store, ordering store, shipping store. Each of these stores can give the data to 15, 20, 30 different views. But hey, I didn't really have to create 15, 30 different view models, right? So catalog store will be only dealing with the catalog. Inventory store will only be dealing with the inventory. So we go from this kind of a relationship where every screen had its own view model to kind of like this, where catalog or anything to do with the catalog is just managed by catalog store. If you had any presentation logic, you will put it in the view, container view. All right. The environment object will be accessed through the use of the screens, the containers. So if you have 300 different small views, try not to access environment object through the sub or reusable views, because that kind of kills their reusability. Yes, there will be some cases where you would need the environment object in very nested views. Those are scenarios that you have to really think about. I proposed this approach, and all of these articles started writing in 2021. I was heavily invested in MVVM, so it was kind of hard for me to even say that I was wrong, but I did it anyway. And I wrote a lot of different articles about that. Even my biggest article, which a lot of companies have read and contacted me about that, hey, we need to talk about architecture. I think we're going in the wrong path. So we're reading your article and all that. In 2021, 2022, these articles just were not met with, there was a lot of resistance. It was kind of like when Jack Bogle introduced index funds in 1976, he received a lot of criticism. So I also faced a lot of criticism at that point. But I kept going and I kept writing articles and creating a lot of videos. Fast forward to 2025, I see change happening. Slowly, but the change is happening. And people are now waking up and they want simplicity instead of complexity. We have a lot of people now talking about the same thing, even Thomas, who is a creator of very large applications. And we also see a different variations of this so-called MV pattern. Some people are just using structs. Some people are calling it services. Some people are calling it controllers. Some people still call it view model, but they use it in a store kind of way. So it's actually really nice to see that people are more open now after obviously they have went through the trouble and the pain of creating 300 view models, that they want something much simpler. So in the end, what I would say is definitely try it out and see if these techniques work. Sometime you would even not need an observable object. Sometime you will need an observable object. It really depends on type of the application you're writing. If you're writing a Swift data application, then my architecture will be completely different. And that's pretty much it. Thank you so much.